Hello friend, myself Sanjeev Dwivedi, and on behalf of Vidyalankar Institute of Technology, I welcome you all in this session. In this session, we are going to talk about some basic operators that are provided to us by Java. And one of the important operator is Bitwise operator. Now, when it comes to Bitwise operator, we should understand that this operator will work on binary level. This operator will work at bit level. Okay, so when you say bit night not, it basically complements the value. It converts 0 to 1 and 1 to 0. So if this bitwise operator is applied on 0 1 1 1, it get converted into 1 0 0 0, which will be decimal 8 in this case particular. Okay, then there is something called as bitwise, and this is just simple demonstration I'm giving to you, because ideally if this is 7 in byte form, then 7 will be, even if in single byte, it will be 1 2 3 4 0 1 1 1, and negating it will be 1 1 1 1 1 0 0 0. So it is not exactly 8, and it is not exactly but a negative binary value. It is actually a negative binary value, but just to demonstrate you that 0 1 and 1 0, this is for what I mean. Okay, and then we have bitwise AND operator. It will perform AND operation. So if we have 0 1 0 1 and 0 0 1 1, so we have 0 1 0 1 0 0 1 1 1 and 1 1 1 0 0 0. So it gives me decimal 1. So bitwise AND operator means what? If both the bits are 1, then 1 else 0. So this is about bitwise and bitwise NOT. Let us take few other example. Let us take few other examples on operators. Next, we have bitwise OR. Bitwise OR, what it does, if both the operands are 0, then 0 else 1. So if basically 0 or 0 will give me 0, else it will give me 1. So we have 0 1 0 1 or with 0 0 1 1. So we have 0 1 0 1 or with 0 0 1 1. So it is 1 1 1 0. That will be 7. So if both the operands are 0, then 0 else 1. So this is your bitwise OR. When it comes to bitwise XOR, in bitwise XOR, what we have, if both the operands are same bit, then 0. Now when I say same, I mean to say 1 XOR 1 or 0 XOR 0. In both the case, it will give me 0. And if they are different, then answer is 1. Now what do you mean by it is different? It means 1 XOR 0 is 1, 0 XOR 1 is 1. So in both the case, it will give me 1. So if we have in this case 0 1 0 1, 0 0 1 1, so we have same to 0, different 1, same 0, 0 1 1 0. This is what we have, 0 1 1 0. So this is how bitwise XOR operator works. Let us talk about few other operators. Then we have left shift and right shift operator. Now basically left shift operator does what? It shifts the overall bits to the left by specified number of bit position. And when we are shifting the bits to left, there will be gaps in the right side, and right side gap will be filled with 0. Right side gap will be filled with 0. This is what is done. It shifts the bit to the left by specified number of bit position. So we have 12. This is 12, and we shift everything by 2 position. So we will lose these two 0. This will shift it here. So what will have 0 0 1 1 0 0. There will be 2 blank position on the right that will be filled with 0. This is what we get. So this is bitwise left shift operator. Similarly, we are provided with bitwise right shift operator. If this is the binary representation of the number and we wish to shift everything to the right, then we will lose 2 rightmost bit. Everything will be shifted to right. So it is 0 0 0 1 0 0. There will be 2 left two blank position on the left filled with 0. So this is the new value that we get, 0 0 0 1 0 0 0. So this is about bitwise left shift and right shift operator. This left shift and right shift operator plays very important role when we are supposed to perform operations. Because when we say 2 multiplied by 4, what ideally we feel like there's a multiplication happening, but it doesn't happen so at system level. At system level, it is nothing but shifting of bit position. So ideally, if you see, if I'm left shifting a bit by one position, I'm actually multiplying the number by 2, and I'm right shifting the bit by every position. I'm dividing the number by 2. So this is how the left shift and right shift operator works. Then there is something called as unsigned right shift. Now, to understand the unsigned right shift, we need to go back to the right shift. Now, see, when it is signed representation of a number, the leftmost bit will be signed bit. Now, leftmost means here, the leftmost bit will be signed bit. Here also, the leftmost bit will be signed bit. Now, the point is, when I'm right shifting the number, everything shift to right. Here, I'm right shifting by 2. So, like the way I said, 0 0 1 0 0 0. So here we just discussed that these will be filled with 0. Now suppose if this number is negative, if the number is negative, the MSBs will be 1. So here instead of 0, there will be some value 1. Now what to do? Now this right shift is basically known as signed right shift. Signed right shift means what? If the number is positive, MSB 0, and I'm right shifting the number, then on the left side, the vacant position will be filled with 0. However, if my number is negative, here the MSB will be 1. And in such case, if I'm right shifting the value, the MSB filled with 1. Now, what will happen is the positive number will remain positive and negative number will remain negative after right shift. So this is the significance of normal right shift. We also call it as signed right shift. Now, if I want to perform unsigned right shift, now what do you mean by that? See, unsigned right shift means what? The right shift operator basically 3 times, 3 greater than sign. We call it as unsigned right shift. We also call it as right shift fill 0. We also call it as right shift fill 0. Now, what will happen with right shift fill 0? If the number is positive, see, if the number is positive, it is as good as right shift operator. It is as good as right shift operator because the number is positive, the MSB will be 0. I'm right shifting it, the left position will be filled with 0. But if my number is negative, like in this case, A is -1. So this is binary representation in 4-byte form. And if I'm right shifting by 24 bits, so there will be 24 blank position on the left side. And this 24 blank position on the left side is not filled with 1. Ideally, what we discussed, if the number is positive, it will be filled with 0. If the number is negative, it will be filled with 1. But when it is unassigned right shift, even though the number is negative, it will be filled with 0 so that the negative number can get converted into a big positive number. So this is unsigned right shift. This is a different. This was not supported in C and C++. So this is one difference operator that you studied in Java. Now, then we have compound operators. Now, compound operator, it simply means that if I'm saying A plus equal to B, it will be A equal to A plus B. If I say A minus equal to B, it will be A equals to A minus B, and so on. So it is these. So if I want to say A right shift equal to 4, so A will be new value that will be generated when A is right shift to 4 bit position. So this is about compound operator, and this compound operator is with every operator like addition, subtraction, multiplication, division, and so on. Now, this is relational operator. Relational operator, it returns Boolean value. Relational operator returns Boolean value. That is, it will return either true value or it will return false. So greater than, less than, equal to, equal to, and not equal to. This is equal to operator, huh? Remember this, and you must be aware of this. This is equal to operator. Okay. So this was relational operator. When we want to, in relational operator, like the way I said, the value, the operands will be values, but the result returned will be Boolean value, true or false. Then we have logical operator. We have when we say logical operator, means operands are Boolean values. Operands are Boolean values. So the operands will be either true or false, and result returned is also Boolean value. The result returned is also Boolean value, again true or false. So if it is A or B, if both are C, if both are false, then false in case of R, or otherwise it is true in case of AND. If both are true, then true, otherwise false. In case of XOR, same. If both are different, then true, else false. Not of true is false, not of false is true. So this is about logical operators in Java. And then we have, yeah, ternary operator. In ternary operator, we have three operands. So the basic is of this form. We have three expression: expression one, question mark; expression two, colon; expression three. Now the working goes like this: expression one will be evaluated. The expression value, expression one, ideally it contains some relation operation, greater than, less than, and something like that. Expression one will be evaluated. If the value of expression one is true, if it returns expression, if the value yielded is true, then it returns expression two. If the value yielded is false, then it returns expression three. So here, like the way we said, if a is greater than 5, it will return expression 2, which is 12, else it will return expression 3, that is 20. So if value, see, A is 10, right? 10 greater than 5 is true. So 12 will be returned and B will be assigned value as 12. So this is about conditional operator. We also call it as ternary operator. It behaves like if else. It behaves like if else. So if, then this, else then this. So if true, return expression 2, else return expression 3, and so on. This is the conditional operator. So here we have basically talked about a general operator. We have not discussed arithmetic operator. That's simple. So these are the operators that we have in Java with us. Uh, this was all about operators, and further topic we'll see in next video. Thank you very much.